Okay, draw a large scaling triangle. So a scaling triangle is a triangle where all three sides have different lengths. So it might look something like this. Okay, and we'll call this point A, B, and C. Now, we want to draw a bisector of angle A. So a bisector is a line that cuts this angle exactly in half. So a bisector might be something like this. Okay. And then draw the altitude from A. Well, the altitude is going to make a right triangle. So it almost is, the way I drew this, it's almost exactly the same. But this is the altitude, where the blue line is the bisector. And the median from A. The median is going to bisect this line at exactly its halfway spot. So, well, let's see. That looks to be about its halfway spot. So the median is going to go from here to there. I didn't draw that very well. Where this distance is exactly the same as that distance. The distance from here to here and the distance from here to here are identical, or they're congruent. So again, the bisector of angle A is drawn in blue. It's a line that cuts this angle in exactly two equal parts. The altitude comes out from here and it hits the other side at a right angle. That's called the altitude. And finally, the bisector will hit this at the midpoint between this and this. So this distance is congruent with this distance. Okay, this time we're going to draw a large isosceles triangle. An isosceles triangle is a triangle where two sides are exactly the same. So this is an isosceles because this is congruent with that side there. Okay, now we'll call this point, again, point A, point B, and point C. The first thing we're going to do is a bisector. The bisector is going to cut this angle exactly in half, and the bisector is going to look like that. That's the bisector. The altitude is going to drop straight down from here, and it's going to hit this at a right angle. So the altitude is this line right here. That's going to hit at a right angle. And the median is going to go from here, and it's going to cut this into two equal parts. So the median is this right here, where this side is congruent with that side there. And so the question is, are these different? No. In an isosceles, the bisector, the altitude, and the median are all the exact same. Okay, we're going to draw a large obtuse triangle. An obtuse triangle is a triangle where one of the angles is obtuse. So something like this. Let me draw. I'll use a ruler. So like this, and my ruler's not long enough. Something like this. Okay. The easiest altitude to draw would be from this point right here. Hitting this at a right angle might look something like this. From this point, we're going to drop down until we hit this line at a right angle. It's going to be, the altitude is going to be outside of the triangle. So we have to kind of draw a dashed line this way. And then we're going to draw a line straight down from here. And I'll draw it in a different color till we hit that at a right angle. So that's the altitude. This here is the altitude of that point. And finally, the altitude of this point, we're going to drop down till we hit this line at a right angle. So I'm going to extend this line like this. And then when we draw the altitude down from here, it's going to be somewhere over here, like this. And we're going to hit this at a right angle. So the altitude of this point was inside of this triangle, but the altitude of this point was outside, and the altitude of this point was outside as well. Here we're going to draw a right triangle. So something like this. Go straight down here. We'll go straight across here. And then we'll connect these two sides like this. Okay, so that's a right triangle. Let me erase a lot of these stray marks. Okay, and obviously this is our right angle. So the altitude from this point right here is this line right here. It's obvious it hits this at a right angle. So this point right here, this line right here, is our altitude from this point. The altitude from this point is this line right over here, because it hits this line side of the triangle at a right angle. Finally, the altitude from here is going to go somewhere over here, and it's going to look like this. And one way to do this is to get a piece of paper, and I made the edge of my paper go along here because my paper has a right angle on it, and I lined up the paper with this corner, and I lined up the top of my paper here, and then I was able to make my altitude that way. So this is a right angle. I was supposed to do it in color, I suppose, so I'll retrace that in black. So the altitude from this point is this side of the triangle. The altitude from this point is this side of the triangle, and the altitude of this point is that line right there. All right, we want an acute scaling triangle. Well, first of all, an acute triangle is a triangle where none of the angles are 90 degrees or bigger. So they're all three angles are smaller than 90 degrees. And the scalene part of it means that none of the three sides are exactly the same length. Okay, to draw this, I'm going to put a baseline down here. And then from here, I'm going to draw one of my angles is going to be bigger than 9 or bigger than 60 but less than 90. Something like, here, let me do that again. Oh. Something like that. And this angle will be an acute also. And what I'm going to do is I'm going to try to make this meet up. So, and I'll end up erasing what I don't need here. Okay, so I'm going to have a point here, a point here, and a point here. This looks like a 90, but it's not a 90. Okay, so there's my acute scaling triangle. Now, a perpendicular bisector is a line that bisects this at a perpendicular. So in other words, we've got to go right exactly in the center, and we're going to draw a perpendicular to that. So I think, again, the easiest way to do this is to get a piece of paper and use my edge of my paper to make a right angle. So this right here would be my right angle. So this, let me extend it on either side, is a perpendicular bisector of this right here, because it bisects at a 90-degree angle, and this are exactly the same. The bisector of this is a point right there. So the perpendicular bisector, again, I'm going to use my edge of my paper to make a 90-degree angle. And I'll do that, and then I'll extend this out here. So that's my perpendicular bisector there, where this side and this side are exactly the same. And finally, the bisector of this point, well, this is the midpoint here. So the bisector will bisect right there at a right angle. So again, I'm going to use my ruler or my paper at a right angle and use the corner of it for a right angle. Okay, and this are identical. So those are the perpendicular bisectors of all three sides.